Now we spoke about integration as the main reason for sticking onto VLSI design. What are the big advantages we get when we integrate things? So these are the advantages. We are able to do more processing. So in a single chip, we can do a lot of things. We can do ALU, we can do DSP, we can do bus architecture, various bus architectures, we can do DMA, we can do a lot of things when we integrate things in a single chip. And we have less area. So most of our VLSI chips or embedded systems these days are portable in nature. We don't want them to be bulkier, or we want them to be as small as possible. So we want them to occupy less area, and we want them to be of higher speed. So when they are close to each other, so when one component, the distance between one component and the next component is less, that is the interconnect length is less, current can transfer from one component to the other component, or one transistor or to the other transistor, or one module to the other module in a short amount of time. So integration makes it possible to have higher speeds, to push for higher and higher speeds. And because they are close to each other and the interconnect length is shorter, we have lower power dissipation also. So the longer the transmission, the higher the power dissipation. So lower interconnects makes it a real low power device. And so we can have a smaller battery, or if we have a better battery, we can run it for a longer period of time and things like that. And portability is another big advantage in compacting things, because it's of less area and it is lighter, so it becomes highly portable. And many things these days are very powerful. iPads, iPhones, smartphones are as powerful as our desktop computers. So portability becomes a big reason why we integrate things. And of course, the last but not the least is reliability. When everything is manufactured in a single chip, when all the components are put together in a single chip, their behavior to the environmental changes like temperature, pressure, humidity, so vibrations and things like that, their changes are similar through the entire chip, because the entire chip has gone through a similar fabrication process. So their behavior is similar. If we have two different chips and they've gone through two different fabrication processes, then we will have two different behaviors. And so because of that, they seem to wear out, and they are not as reliable as single chip devices. So that is why we prefer to design SoCs and try and put everything, including RF, into our single chip. So these are some of the major reasons of integrating things into a single chip.